What is up, guys? I'm back here with another video, and it has been a while since I made a video. I got kind of distracted with some other ideas I had with my project, and I realized I just need to get back to my original plan. And that happens sometimes. I think it's just important, you gotta like catch that before you get to like, oh shit, it's been like a whole month and I haven't done anything. So anyway, back to the topic here. So this is my EDA, exploratory data analysis, and I'm looking for feedback, but I'm also just sharing the process here. So if you have any feedback on how this could be better, please don't hesitate to let me know in the comments or on LinkedIn or whatever. So this, like I said, this data set is, as mentioned before in earlier videos, only has 60 rows right now, really small data set. So do keep that in mind when looking at this project here. So the first thing I looked at was the landing pages and analyzing landing pages of the leads in this data set. So the idea here is that in advertising and digital marketing, when you have a landing page, that's like, okay, you got an ad, user, person on their phone, whatever, clicks on the ad, they get taken to a landing page. So it's important that you have a landing page that, is designed right in a way that leads to people actually buying from you or taking the action that you want them to take. So we've calculated I came up with this formula called landing page complexity. So basically, the higher the score is, the more like kind of overwhelmed the user will potentially feel from looking at it. So the way you calculate landing page complexity is you take number of words in the landing page times the number of trigger words, which are words that trigger a call to action. This is like buy, today, now, call, book, session, etc. And then you have links, which is the number of like everywhere the user can click. So if you've got like, okay, get the free ebook, book a session, attend a webinar, read the blog, like all these links versus just like buy. Anyway, so I've looked at the correlation between these. So overall, surprisingly enough, like I said, I'm looking at the correlation between the landing page, these details on the landing page, and the return on ad spend, because the idea is the more complex your landing page is, the more overwhelmed the user feels, the less likely they are to take any action, leading to a leak in your ad spend, which is important because this is kind of a thing. A leak in your leaky ad spend is the thing that the software particularly helps with. So we can prioritize people with this kind of problem because we can help them more. But anyway, looking at this detail, the number of the what am I looking at? Yeah. So I found overall, surprisingly enough, landing page complexity actually has a positive correlation with return on ad spend, which is not what I would have expected. But I dissected it and looked at each individual feature. So I looked at words, and words have a negative correlation. So the more words, the less likely the user is to take action. However, or not necessarily less likely, but the less return on ad spend the company has. And trigger words have a slight negative correlation, not as much of a negative correlation though as words. And then links actually have a slight positive correlation between return on ad spend and number of links. So I think this is just kind of theorizing about it. I have a feeling that's potentially it's a very, very slight positive relationship, but I think the only reason for it there might be an outlier somewhere, but it's also possible that like when there's multiple places to click, there's multiple places to buy. So like they kind of improve their odds of getting someone to purchase something, but I'm not sure about that. So I've looked at the visualization, just a little scatter plot here, and kind of just from looking at it, it looks like there's kind of a dip in at return on ad spend after around 700 words on the landing page. And it takes after about 10 words on the 10 trigger words, you start dipping a little bit. And then with links, I was not able to find a whole lot of information as much. Just because there's not that many, there's like once you get past like 7 or 8 links, there's just not that many people have more than 7 or 8 links on their landing page. And from looking at this, I decided to do a statistical test to see if there's a difference in return on ad spend for companies that use less than 700 words on their landing pages versus more than 700 words. And I found that I was not able to prove it. So there's no statistical proof that this happens, but it does seem to be somewhat the case from looking at it. And I compared the averages. The averages are a pretty big difference. You know, we got an ROAS of 8 for under 700 words, but that drops down to 4 for the, you know, group with over 700 words. But I think it's just an outlier, because if you look at this guy, this little blue dot is like way up here. And then I compared the medians, and the medians are more or less the same. So probably what's going on here is it's really all the same, and there's just like a big outlier here. Just a big outlier that gets 120 ROAS, which is insane. In fact, maybe the data was even collected wrong. And then I did some bootstrap sampling just to take another look at it, because I was a bit surprised that I couldn't prove it. So we've got a distribution function here, and the distribution is kind of wonky. It's kind of just up and down, kind of all over the place for the under 700 words. It's probably the outlier messing with it. However, the group with over 700 words, this distribution is much more normal. It's pretty much a normal distribution here. Okay. And then I looked at the lead with the highest return on ad spend, and their clickfunnels.com. Most likely the reason for this is because they're doing over $100 million in revenue a year. And I don't know if that's necessarily the reason for it, but it's also worth noting they're like a giant company. So the next one is Actionable Insight. Yeah, I've talked about that. So now I did some confidence intervals. So the first, this isn't really that valuable question, but the first one I looked at was the closing rate, just to kind of practice. And so the idea here is, I already know half of these leads purchase the product, which I think overrepresents. Like realistically, it's probably like 20% is what their actual closing rate probably is. I just wasn't able to get that many non-customers. But but basically what we did, what's going on in a confidence interval is you're taking samples of the data set for a certain number of times. In this case, it's 1,000 samples. And you take the mean, the average of each sample, and then you kind of like form a distribution, and you kind of like, you take basically you take everything that's within a certain amount of standard deviations of the mean, like 2 standard deviations of the mean. And that way you get a 95% confidence interval. Only doing 1 standard deviation, you get a 68% confidence interval. So right here, it looks like basically of these sample means, right, 95% of them have a closing rate of within the sample of higher than 38%, but less than 63% right here. And then we have a distribution of the closing rates. And as you can see, it kind of starts picking up around 40% and starts dipping off around 65%. And now we did a confidence interval for the revenue of our customers, like how much are they making on average. And for our customers, and these are not leads in the data set, these are people that actually purchased the product. We find 95% earn between around 400, basically between $500,000 and $6.2 million a month. And that's 95% of them. And 68% earn between 1.9 million and 4.6 million a month in revenue. Actually 4.7 a month, 4.7 million a month. So yeah, as you can see, a lot of these companies are pretty high performing companies doing 8 figures. And then we looked at, here's an actual distribution of it. So the blue is the customers, the orange is the non-customers. And don't be confused by the blue being higher, because it's actually, it's the x-axis that determines the note that's tracking the number of revenues or the amount of revenue. So it actually looks like there's a slight difference, but it probably reject the null hypothesis if there was if I was to do a test to say like, okay, to test if these were different, I'd probably have to accept the null hypothesis that they were not different. So I did a statistical test actually for ad spend and for revenue. And it's odd because I used a t-test, because reason for that is because the sample size was at or under 30, which I've been told generally you want to keep it simple using a t-test for that situation. And yeah, we rejected the null hypothesis. So basically we're not able to find a statistical significant difference in ad spend between the customers and non-customers or in revenue. However, when I did a chi-square, which is a different statistical method for statistical testing, and I actually had to reject the null hypothesis then. So like I said, given the context, I think a t-test is more appropriate, but I'd like to know kind of like why I reject the null on this chi-square, but I accepted it on the t-test. But anyway, here is that same visualization again. And now we're doing a chi-square independence test. So up until this point, all the statistical tests I've done were all centered around, okay, like here's 2 samples of numbers or 2 populations of numbers, whatever, like how are they different? Let's compare them. This is more like, okay, we've got just like counting these categorical features. So we're like, okay, we've got, these are our customers that did not, these are non-customers, these are customers, these are their number of leads that are in each business model. So we're looking at basically like what business model is this, what kind of business model does this lead operate with, and are they customers or not? And we were not able, like we had to accept the null hypothesis. We were not able to reject it. So there doesn't seem to be much statistically proven difference between business model and whether or not they purchased the product. However, this product is actually tailored most tailored towards towards info businesses that sell coaching services or courses and things like that. So there we go. Then I looked at Twitter sentiment. So the idea here is that like I said, this is just my thought process for analyzing this, is that, okay, so if you have a company that has poor sentiment on Twitter, sentiments like how the public receives, or the public's kind of like the public's perception of your Twitter profile. Negative meaning bad, positive meaning good. So like negative. So basically, like I'm saying, if a lead has a negative sentiment on Twitter, it's a sign that their product's not good. And if their product's not good, then we can't really help them with any like hyper targeted optimized advertising. So it's kind of like, okay, if your product's not good, then you don't even need to worry about advertising because you're just going to be wasting your money, and you should focus on making your product actually good, not hyper optimizing your ads. So that's kind of like the idea here. And we're looking at return on ad spend and their sentiment. So the idea is that for companies that are, perceived poorly on Twitter, they're what does they say? When they're received poorly on Twitter, their ads don't convert well and they have a low return on ad spend. That's the idea here. And we're testing to see if that's actually true. And we did run a t-test, and we were able to accept the alternate hypothesis and fail to accept the null hypothesis. So essentially, this means that those companies with positive sentiment have significantly better return on ad spend than those with negative sentiment. So basically, the idea is to avoid companies that have low negative sentiment, and avoid leads that are like that, because that means that they're less likely to benefit from the service. In which case, we don't want them buying it because will make the company look bad. And now I did this weird thing where I took the basically every lead in this data set, their website has been ranked, like in terms of how popular it is. So the higher the rank, lower the number, basically, the more likely, or like the lower the number, like the more visit it is, the higher ranked it is, the more popular it is, right? So we're seeing like, do these companies like that have higher revenue than the rest of them? That like the top 5, like grabbing like the top 5 highest, like the top 5 most popular sites, companies with the top 5 most popular sites in the data set, those 5 companies compared to the rest of the companies, is there revenue a statistically significant difference? That's what we're looking at. Because on one side you'd think, okay, obviously the higher, like the better the ranking score for the website, higher ranked website it is, the more revenue they'll generate. But then again, a lot of people, there's a lot of like really dumb free stuff that's just entertainment that people just look at, that's really popular. But anyway, that doesn't really generate much revenue. But anyway, so looking at it, I did some bootstrap sampling, because this is a very tiny sample to really look at. So bootstrap sampling is you pretty much resample your own data at random to create artificially larger samples to run statistical tests on. You could even do machine learning on it if you wanted to. So anyway, comparing this is the not in top 5, and this is the in top 5. So again, much more revenue going on here. This is kind of like centered around like $500,000 a month in revenue, whereas this is centered more like $1.5 million a month in revenue. And we did a chi-square test, and we were able to reject the null hypothesis, meaning that we're considering it reasonable to believe that the highest ranked websites do generate more, or the companies with the highest ranked websites do generate significantly more revenue than the rest of them. And the insight here is that when you have companies with sites ranked in the top 4,000 are much more likely to generate much more revenue, and this is an opportunity to upsell or charge more for if we find that there are companies in the top 4,000 most visited sites. And the source of that data came from Full Contact, the Full Contact API, in case you're curious. So yeah, that is the project. So, or that is the EDA anyway. I'm going to move on to working on a dashboard in Tableau, most likely, and also looking into the modeling techniques, seeing if there's something I can actually model with this data. And so anyway, that's been the video. Like, comment, and subscribe, and I'll see you in the next one.